Hi guys, Ms. Zarnowski here. Today I want to take some time to go over your Topic 7 practice test. And so at the top it says Topic 7 review. Hopefully you had a chance to get most of or all of this done yesterday. And so I want to go through the answers with you. You should follow along with your own practice test and make any corrections on there for questions that you have wrong or questions that you didn't do, because I want you to be able to use your practice test to study for your test tomorrow. Okay. All right, so let's get started with number 1. Number 1 says, for a dilation with a scale factor not equal to 1, how do the angles and the side lengths of the pre-image relate to the angles and the side lengths of the image? So a dilation with a scale factor not equal to 1 means we're going to get an image that is a similar polygon from the pre-image. So if that's A and that's A prime, and this is a dilation of this, that means they're going to be similar. The figures will be similar. And so what does it mean for two figures to be similar? Well, corresponding angles are congruent. So this angle will be congruent to this angle congruent to this angle, and this angle congruent to this angle. And then corresponding sides are not congruent because it's a dilation, so the corresponding sides will either be bigger or smaller, but they will be proportional. So angles are congruent, sides are proportional. All right? Okay, number 2. Number 2 says, given that triangle ABC is dilated to triangle GHI, where triangle ABC is the pre-image and GHI is the image. So we're going from here to here. Find the scale factor. And so over here I put a little key that says scale factor is the ratio of the side length from your image to the side length of your pre-image. So over here, scale factor is going to be a side length from the image, and they said GHI is the image, so I'm going to pick 6, that's the right side, to the side length, the corresponding side length of the pre-image. And so ABC was the pre-image, the corresponding side length would be 18, because I know that GH corresponds to AB. And so AB is 18. And I'm going to simplify that down, divide those both by 6, and I get 1/3. So I want to check to make sure that makes sense. When I went from triangle ABC to triangle GHI, my image got smaller, so my scale factor should be less than 1. And it is. So that one makes sense. Okay. This next one looks like we have maybe some trapezoids. So find the scale factor. Here we have a small trapezoid and here we have a large trapezoid. I know that the small one over here is the pre-image, because this one on the right has to be the image since it has the little prime symbol after the W, X, Y, and Z. So we go from W to W prime. So this is the image. This is the pre-image. So scale factor is the ratio of a side length from the image, I'm going to use 20, to the side length of the corresponding side in the pre-image, 15. So let's divide those. Well, let's see here. These are both divisible by 5. 20 divided by 5 is 4. 15 divided by 5 is 3. So we have a scale factor of 4/3, which is bigger than 1. That makes sense because we go from something smaller to something bigger. Okay. And last but not least, over here we have triangle LM. Oops, I think this was supposed to say N. And we're going to L prime, M prime, N prime. And so this must be the image. So I'm going to grab a side length off of here. I'm going to take L prime, M prime. And this was the pre-image then. And the corresponding side would be LM, which is 12. Simplify this. They're both divisible by 3. So 3 divided by 3, or 9 divided by 3 is 3. 12 divided by 3 is 4. So scale factor is 3/4. That is less than 1, which makes sense because we're going from a larger figure to a smaller figure. Okay, next let's take a look at number 3. Number 3 says find the coordinates of the vertices of each image. So we want a dilation with a scale factor of 0.5 of triangle ABC, given that the coordinates of ABC are the ones that we see here. So dilating by a scale factor of 0.5 means we're going to take A, and A prime is going to be my coordinates from A times a scale factor of 0.5. And so B prime is going to be, oops, I forgot the y coordinate from A, didn't I? Let's fix this real quick. Okay, so I just did the x coordinate. I need the y coordinate, which is -2 times 0.5. And so we get A prime to be half of 8 is 4, and half of -2 is -1. So then B prime is going to be -4 times a half, and 3 times a half. And C prime will be 6 times a half, and 0 times a half. All right, so B prime, we get -4 times half is -2. 3 times a half is 1.5, 1.5. And then for C prime, 6 times a half is 3, and 0 times a half is still 0. Okay? And now we're going to do the same thing in part B. This time we just want a dilation with a scale factor of 3. So that means we're going to take our coordinates from x, y, and z and multiply them by 3. So x prime is going to be 4 times 3, which is 12. 2 times 3, which is 6. Y prime is going to be 3 times 3, which is 9. -8 times 3, which is -24. And Z prime is going to be 0 times 3, which is 0. 5 times 3, which is 15. Okay. All right, and then the last one on this page, number 4, says, is the dilation in 3A an enlargement or a reduction? Well, looking at the dilation scale factor, it's 1/2. Since that is less than 1, it's a reduction. So it's a reduction because the scale factor is 1/2, which is less than 1. Okay? Likewise, in 3b, we have a scale factor of 3, so that's an enlargement because the scale factor of 3 is greater than 1. Okay, so when your scale factor is less than 1, it's a reduction, and when it's greater than 1, it's an enlargement. All right? All right, let's look at number 5. Number 5 wants me to graph and label a dilation under the given rule. So here I have a quadrilateral. It looks like maybe a square, but I'm not positive. STUV, and we want to dilate that with a scale factor of 2. So it should be an enlargement because our scale factor is greater than 1. So I'm going to start by getting my coordinates. Right now, S is at 1, -2. T is at 2, 1. U is at -1, 2. And V is at -2, -1. And so for my dilation, I'm going to multiply all of my vertices by 2, since that's my scale factor. So S prime is going to be 1 times 2, which is 2, and -2 times 2, which is -4. 2, -4, and label it S prime. T prime is going to be 2 times 2, which is 4, and 1 times 2, which is 2. So 4, 2 is T prime. U prime is going to be -1 times 2, which is -2, and 2 times 2, which is 4. So I'm going to graph -2, 4, and label it U prime. And V prime is going to be -2 times 2, which is -4, and -1 times 2, which is -2. Okay. And now I'm going to graph this quadrilateral. Should be twice as big. Okay? All right, very good. Same thing over here, this time with a dilation of 1/2. So we should get an image that is smaller. So I'm going to start with my vertices. E is at 2, -1. F is at -1, 2. And G is at -2, -1. And so my dilation, or my scale factor of 1/2 means I'm going to multiply each of those by 1/2, or divide by 2. So E prime, we're going to have 2 times half is 1, -1 times half is -1/2. That's E prime. F prime is going to be -1 times half, which is -1/2, and 2 times half, which is 1. So there's F prime. And then G prime is going to be -2 times half, which is -1, -1 times half, which is -1/2. So there's G prime, and then I'm going to draw my image. Okay. All right, very good. And then part C, they already give us the graph of the pre-image and image. And so my pre-image is XYZ, which is this smaller shape, the smaller triangle, because I know the image is the triangle that has the primes on the vertices. So clearly this is an enlargement because my triangle gets larger. So we know that means our scale factor has to be larger than 1. So that gets rid of D or C and A. And now the question is it larger by a scale factor of 2 or 3? Well, let's get the side length of the image, the new one. 1, 2, I'm going to pick this horizontal side because it's easy to count. 1, 2, 3, 4, 5, 6, 7, 8. So that's Z prime, Y prime is 8 over the pre-image, ZY, which is 1, 2, 3, 4. And so that means my scale factor is 2. So the answer here is D. Okay. Figured out if it was an enlargement or a reduction and narrowed my choices down. And then I found the side length of the image and the corresponding side length of the pre-image and got my scale factor. So this is the scale factor. Okay. All right, let's take a look at 6. Part A says, given triangle CDE and STU, what is the measure of angle E, D, S, and T? Well, it looks like these are potentially similar triangles. I'm going to confirm that by checking if the sides are proportional. Because if they are, then my angles should be congruent. Remember, that's the definition of similar from number 1. All right, so I'm going to start with side CD, which is 26, over what I think is the corresponding side ST, so 39, yep. And if I divide those two numbers, I get 0.6 repeating. Okay, then I'm going to look at DE, which is 12, over TU, which is 18. Let's divide those, and we get 0.6 repeating. And then lastly, we have CE, which should correspond with SU, which is 20 to 30. And when you divide those, we get 0.6 repeating. So since they have all the same ratio for the corresponding side lengths, that means they are proportional, which means yes, these are similar. So corresponding angles are congruent. So that would mean C corresponds to S. So since C is 41, S is also 41. And U corresponds to E. So since U is 98, E is 98. And then for our missing angle in each triangle, we'll use that triangle sum theorem that you've learned about in an earlier topic that says all three angles must add up to 180. So I'm going to take 180 minus 41 minus 98. 180 minus 41 minus 98, and that's 41. So that means angle D is also 41. And so D corresponds with T, so T is also 41. Okay. All right. We're going to try that same thing with B next. First, we've got to figure out if these are similar. Okay, so how do we go about showing these triangles are similar? So first of all, I can see that we have a pair of vertical angles. So I know that angle GEF is congruent to angle MEN, because they are vertical angles. And then I can check to see if my corresponding sides are proportional. So if GE is 40, that corresponds with SU. Oh, I think this triangle is named wrong. It's supposed to be E, F, G, E, M, N. So I'm going to make that change here. So we have GE is 40, so that'll correspond with NE, which is 10. So that gives me a ratio of 4/1, or 4. And then I have FE, which is 28, and that corresponds with ME, which is 7, and that simplifies to 4. So we do have similar triangles by side angle side similarity. So then I know corresponding angles are congruent. So angle FEG is congruent to MEN because they're vertical and because they're corresponding. If angle G is 50, then angle N is 50. And since angle M is a right angle that's 90 degrees, angle F is a right angle, which is 90 degrees. And then I can subtract from 180 to get my vertical angles. So 180 minus 90 minus 50 is 40 degrees. So that makes these two angles each 40 degrees. Okay? And then finally, part C, given STU and DEF, what is angle E? So I'm looking for this angle right here. So let's check to see if they're similar by checking the ratios. So ST is 15. That would correspond with DE, which is 6. Divide those each by 3 and we get 5/2. TU is 10. That corresponds with EF, which is 4. Those are both divisible by 2, so we get 5/2. And then SU is 20, and that corresponds with DF, which is 8. Those are both divisible by 4, so we get 5/2. So since all of our ratios are the same, the side lengths are proportional. So yes, these triangles are similar by side similarity. Therefore, our corresponding angles are congruent. So if angle S is 29 degrees, then angle D is 29. And so we have angle F is 46, and so if I need angle E, I can take 180 minus 46 minus 29. And I get 180 minus 46 minus 29 is 105 degrees for angle E. Okay? Alright, number 7. A says, given triangle ABC is similar to triangle DEF, which must be true? So before I start looking at my options, I'm going to draw a picture. So I'm going to draw a picture of a triangle, label it A, B, C, and another triangle, and I'm going to label this correspondingly. Since A corresponds to D, I'm going to start here and go this way, E, F. And I know for similar triangles, corresponding angles are congruent. So let's check our first option. BC is equal to EF. Well, since they're similar, they don't have to be equal. They just have to be proportional. So A is not necessarily true. AB is to DE as AC is to DF. That is true because those are corresponding parts. The measure of angle C is congruent to the measure of angle F. That is true because they are in corresponding parts. And the measure of angle A to the measure of angle D equals the measure of angle B over the measure of angle E. Well, since our angles are congruent, A divided by D should be 1 since they're the same. And B divided by E should be 1 since they're the same. And does 1 equal 1? Yes, so that should also be true. Okay. And let's look at B. Again, I'm going to draw a picture to help me answer this question. Given triangle GHK is similar to triangle LMN, select all that apply. Alright, I know corresponding angles are congruent. So H is congruent to M. That is true since they are corresponding. A measure of angle G plus measure of angle H plus measure of angle K equals 180. Well, that is true because the three angles of a triangle should add up to 180. HK over MN equals GK over LN. That is true because those are corresponding. So we did 1 to 1 and then 2 to 2. Yes, those are corresponding, so that works. And then angle K is congruent to angle L. That one is not necessarily true because they are not corresponding parts. Alright, moving on to number 8. It says, what are the 3 similarity shortcuts that we can use to prove 2 triangles are similar? So we know to be similar we need all 3 angles congruent and all 3 corresponding sides to be proportional. And then the 3 shortcuts we saw were side, side, side. If all 3 pairs of corresponding sides are proportional, then your triangles are similar. Angle, angle, similarity. As long as you have 2 pairs of corresponding angles that are congruent, your triangles are similar. And side, angle, side, similarity. If you have 2 pairs of corresponding sides that are proportional and the angle in between them is congruent, then your triangles are similar. So B says, what condition would prove that triangle DEF is similar to triangle JKL? Well, I see that I have angle D is congruent to angle J. So that's telling me I'm probably going to want to use one of the shortcuts that includes an angle. And since I don't know any other angles, and none of my options have anything to do with angles, I think that means angle is out. We want side angle side. So right now, because we have DE is 12, and KJ equals 8, and DE and KJ are in corresponding places, I have side angle. I would really like to prove that the other side, on the other side of that angle, is proportional. And so we have a scale factor. If I divide these both by 4, I get 3 over 2. So that is equal to 1.5 if you divide 3 by 2. And so what I would want is I would want the side on the other side of the angle to be in a ratio of 1.5 to 1. So I would want DE or DF to LJ or JL, DF to JL to be in a ratio of 1.5 to 1. DF comes from the larger triangle, so that needs to be 1.5, and LJ or JL comes from the smaller triangle, so that needs to be 1. So it looks like C. C would prove that the two triangles are similar. Okay, number 9, it looks like we have some proportionality theorems. We're going to set up a proportion, cross multiply, and solve. So for A, we've got some parallel lines here that are cut by transversals. We want to find AB, so I'm going to put my X there. And so I'm going to start over on this side. If I know this whole piece is 24, 24 minus 16 is 8. I'm going to put an 8 here for DE. So now I can set up the proportion. 28 is to X as 16 is to 8. And then we'll cross multiply. 16 times X is 16X equals 28 times 8. So 28 times 8 is 224. Divide both sides by 16. X is 14. So let's double check what did they want us to find. AB, and AB is X, so AB is 14. Okay. On our next one, it wants us to find the length of the question mark. So in order to do that, first I'm going to want to find this smaller piece, and then I can add them together. So I'm going to put an X on this smaller piece, and now I can set up the proportion 16 is to 12 as X is to 21. When I cross multiply, I get 12 times X equals 16 times 21. 16 times 21 is 336. And if I divide by 12, I get that X is 28. But I wasn't looking for X. I'm looking for the length of this full segment, which is 21 plus 28, which is 49. Okay. And then finally over here, it says find VW. VW is this little piece here. So I'm going to put an X there. And so first of all, I want to find VZ. And so I know if this whole piece from V to Y is 80 and ZY is 50, then VZ is 80 minus 50, which is 30. So now I can set up a proportion. X is to 30 as 62.5 is to 50. And I can cross multiply 50 times X equals 62.5 times 30. And 62.5 times 30 is 1,875. Divide both sides by 50, and I get X equals 37.5. And so I was looking for VW, and VW is X, so VW is 37.5. Okay. All right, moving down to number 10. A, we are solving for X, so I'm just going to set up a proportion here. 15 is to negative 10 plus 3x, as 12 is to 16. Or you could have done 15 over 12, negative 10 plus 3x over 16. That would work too. And then I'm going to cross multiply. 12 times negative 10 plus 3x equals 15 times 16. And so I get negative 120 plus 36x equals 15 times 16 is 240. I'm going to add 120, and I get 36x equals 360. Divide by 36, and x is 10. So what were we asked to find? We were asked to find x, so that's our answer. Okay. Over here in B, before I set up my proportion, I'm going to start by taking this whole piece. 18 minus 6 is 12, and putting a 12 right here. Okay, and then I can set up a proportion. 14 is to 6, as 8x plus 4 is to 12. Okay, then I'll cross multiply. 6 times 8x plus 4 equals 14 times 12. So I get 48x plus 24 equals 168. Subtract 24 from both sides. And I get 48x equals 144. Divide by 48. And I get x equals 3. All right, and our last page. So for these we have some angle bisector theorem problems, where again, because this segment is the angle bisector, cutting this angle in half into two congruent angles, that divides my triangle proportionally. So we can set up proportions to solve for x. So for 11a, I'm going to set up the proportion 4 over 3 equals 8 over x minus 2. Cross multiply, 4 times x minus 2 equals 8 times 3. So I get 4x minus 8 equals 24. Add 8 to both sides, and I get 4x equals 32. Divide by 4, and I get x equals 8. Okay. Over here, the first thing I'm going to do is find this little piece. If I know the whole length is 7 and part of it is 3, then the other part must be 4. 7 minus 3 is 4. And now I'm going to set up the proportion. 3x minus 1, I'm going to go to 4, equals 6 over 3. Again, you could set up a different proportion. You could go 3x minus 1 over 6 equals 4 over 3, as long as you have corresponding parts. Okay, so to cross multiply, we get 3 times 3x minus 1 equals 6 times 4, which is 9x minus 3 equals 24. Add 3 and we get 9x equals 27. Divide by 9, x is 3. Okay. Last two, we want to find a side length, so we got to start by solving for x. So I'm going to set up the proportion here. 2x plus 6 over 8 equals 6x minus 2 over 14. Cross multiply, I get 8 times 6x minus 2 equals 14 times 2x plus 6. Distribute, I get 48x minus 16 equals 28x plus 84. I'm going to subtract 28x, and I get 20x minus 16 equals 84. Add 16, and I get 20x equals 100. Divide by 20, and x equals 5. But we're asked to find WZ in the problem. So WZ is 6x minus 2. So I have WZ equals 6 times 5 minus 2, which is 30 minus 2, which is 28. So WZ equals 28. Okay? And our last problem over here, I'm going to start by setting up a proportion to solve for x. I'm going to do 3x plus 4 over 15 equals negative 4 plus 2x over 6. So I get 15 times negative 4 plus 2x equals 6 times 3x plus 4. Distribute, I get negative 60 plus 30x equals 18x plus 24. I'm going to subtract 18x from both sides, and I get negative 60 plus 12x equals 24. Add 60, I get 12x equals 84. Divide by 12, I get x equals 8. But the question's asking for FH. FH is this whole length here. So first I'm going to start with FG, which is 3x is 8. 3 times 8 plus 4, which is 24 plus 4, which is 28. And then GH is negative 4 plus 2x. Our x is 8. So we get negative 4 plus 16, which is 12. So FH is 28 plus 12, which is 40. Okay, so there you have it. That's your full practice test. Your test tomorrow will look a lot like that, a little bit shorter, but most of the problems are going to be pretty similar. So make sure you study, and good luck.